Hey, this is Mr. Word. I'm going to go over Geometry Do Now 21.2, so week 21, day 2. And I want to just flag this for you. Chapter 6 is a pretty short chapter, and the concepts are fairly straightforward. And I'm going to see if we can address them using do nows and exit tickets, because I think you'll be able to grasp them pretty quickly. We'll experiment with that today. Today's do now and exit tickets will cover Chapter 6, Section 1, and see how that goes. So the first thing you'll want to do when you read these is I'm going to introduce a few definitions, and I want you to consider them and see what you make of them. So the first thing is a new definition. It's something called a foot of a line. So if a line intersects a plane, the place where it intersects the plane is called the foot of the line. And so based on the definition above, what is the foot of line RS? So let's find RS. There's R and there's S. So that's RS. What is the foot of RS? Well, all of RS is on plane N, so you can't really say there is a foot for plane N, but it does intersect with plane M at point P. So point P would be the foot of RS. So point P is the foot. Okay, that is the foot of RS. Okay, now we got a couple other things we're going to go over. So the following postulate and theorems show ways to determine a plane. So one you've run into before, 3 non-collinear points determine a plane. So if I have 3 distinct points in some sort of triangular pattern, that will determine a plane. And then if you have a line and a point that's not on the plane, Theorem 37 says that also determines a plane. So here we have sort of an example with a little post and what's called a wooden horse. It's supporting some sort of flat surface, and that would be considered sort of a model of a plane. So a line and a point that is not on the plane determines a plane. So it's a non-collinear point. Theorem 38, 2 intersecting lines determine a plane, and also Theorem 39, 2 parallel lines determine a plane. So let's consider this. Along with A and B, name a point that determines plane M. So this is plane M, and this is A and B. So we could pick either point V or point W. We can't pick point P because it's collinear with AB. So V or W. So points V or W would do the job because they would determine a plane. P would not, since it's collinear. All right, along with line AB, what is another line that determines plane N? So this is plane N. So along with line AB, well, the line that's identified on here is RS, and it's an intersecting line, though you could get creative with this as well and say, okay, BR or AR would do the job as well, and AS and SB would work too. So the one that is most obvious, line RS, also known as RP or SP, but RB, RA, BS, and AS also all determine plane N along with AB. Okay, because they intersect AB. If they intersect AB or if they were parallel, and there's no lines that are clearly defined as parallel to RS or to AB, but there are definitely lines that intersect AB. AR, BR, SB, AS, all of those intersect. And so intersecting lines determine a plane. Okay, along with point S, what is a line that determines plane N? So let's find point S. So there's point S. And there are a few lines that would determine plane N. The most obvious one is AB, AB, also known as AP or BP. Those are other names for it since P is on that line. Another one, okay, you could also say RB. Let's see. You can't say BS because S is on BS, and you can't say AS because S is on it, but you could say RB or AR. Those would work as well. So those lines work. Now, can you hold up two pencils so that they do not intersect and so are not parallel? So you absolutely can. You can hold up a couple of pencils so that they don't intersect and are not parallel. Would they be collinear? So lines that do not intersect and are, I think I need to reword this one. So basically, I want you to explain why they would not be collinear. So this actually, I have to redo this one. This actually states this. So lines that do not intersect and are not coplanar are called skew lines. But the basic thing is the fact that they don't intersect and they are not parallel, those are determining factors for a plane. If there are neither of those things, then you will not be determining a plane. All right, I'm going to stop there, and I hope that was helpful.